It's a little cold out there. Okay, so this is recording. So I record all my classes so that when you miss, you can watch if you want, but no one does. I see the analytics, I know, but I feel like I need to anyway. Okay, so let me get rid of this because this is not what we're doing. Pull up the numerical. I was too lazy to copy that into the stuff that we're actually doing. Where is it? If I use this, will that help? Weird. Why is it not showing up here? Oh, here it is. Oh, there it is. Numerical methods. That's what we're doing. Okay, so it'd be nice to know what numerical methods is, but I guess before we do that, we should probably deal with the syllabus. There is a definition or sort of. No, there's not because I didn't copy it. I guess we can pull it up. Sorry, the syllabus has, but I fixed everything, but apparently I did not. There are two things I see. That's okay. That's okay. We can fix it. The rest of it should be okay. Does everyone have a copy of the syllabus that I gave you? Okay. It says numerical methods at the top. Let me get the corrections so that we can know what this numerical methods thing is. So, well, the first thing is you know who I am, and if you don't, I am who I am. John Noonan. Nice to meet Matthew here. Is a newcomer of sorts. I'm sure you've been on campus, but you'll find me in FA 101. That's the faculty hall. Are you familiar with faculty hall? Yeah. Okay, so it's first office as you walk in the building. Everyone can email me, set up appointments, and you don't need an appointment, of course, to come visit to me. But if you want to make sure I'm there at 6 a.m., you're going to have to make an appointment because I'm normally not on campus exactly at 6, maybe a little after. Just a sec. Maybe if I just stare at this. Oh, there it is. I knew I had a bookmark for the catalog here in a bit. So you have my phone number, my text number, the cell phone if you need to contact me. So the course description is where things are going awry. So let us find the correct course description. It'll just take a sec here. Find. Let's see, numerical methods. Let's see, where is it? Oh, well, of course, it's not the description. We'll get it. We'll get it. Almost. Try one more time. Come on. There it is, finally. Okay, so so this is what I should have copied and put, and it's not making it bigger for some reason. Oh, there it is. Nope. Guess it's not going to get any bigger unless I press this. Oh yeah, there it goes. Okay, so this is what should have gone under course description, is a study of systems of equations, quadrature, and approximation of solutions of nonlinear equations, special emphasis given to error analysis and machine computation. And the prerequisite, so that's the second error. It should say under prerequisite, under course rationale. Almost the same thing, but it would be the Calc 2. Calc 2 is the thing. So that really isn't very helpful, is it? And so before we go on, it might be helpful to actually figure out what in the world is numerical methods. Now, I joked a little bit when I came in. There are only two of you here, and said, oh, is this basic algebra? Eli was excited to think that maybe that's what we were going to do. So he was cheering and saying, yes, that's what we have here today. Joking aside, basic algebra is part of numerical methods because numerical methods is getting computers to do the things that we've been doing with analytic tools up until now. And so basic algebra. So let's I'm just going to jot down some of the things that we might do in this class. And one of them is, I'm not going to go so far as to say basic algebra, but let's say solve equations. Solve equations. I don't know if you've had this experience, but I've had the experience of having an equation that was too hard to solve. I know, it seems almost impossible that there would be such a thing. But there are some equations that are really hard to solve. I mean, you throw a trig function in with an exponential function and maybe a polynomial, just throw it all together and put it in a blender and hope for the best. You're going to get some equations that are really hard to solve. So numerical methods are methods for solving numerically equations. So what other tasks have you learned to do mathematically up until now in various math classes? What was that? Quadratic equations. So that's a sort of a subset. You're solving equations. You have quadratics. Good. So those are some basic, but there's some other courses. We've done more than just algebra, haven't we, in the past? I know some of you did some other things just this fall. So what other things did you do? You integrated things? Okay, that's good. Integrate. And I know that I come up against, I mean, I could just write one down now. Try sine of x squared. Put x squared inside sine. Try to integrate that thing. You're not going to be able to. So that's a good example of a function that you can't integrate the normal way. And so we have to rely on some other things. That's what numerical methods are for. It's for figuring out how to integrate things that we don't know how to. What else have we done in the past in other math classes maybe?
Solving for probabilities.
Okay, so solving for probabilities. And so let's see. So that's kind of an application. So let's see, probabilities. And to do that, you're going to be using, sometimes you're using calculus. So sometimes you're integrating. Sometimes you're solving equations. Sometimes you might do some other linear algebra. Whoops, algebra. Although we never really named it as such in probability, but when you're doing probability problems, you might be doing this. So that's other stuff that if it's too hard to do, and certainly once you pull the normal curve into the picture, all that whole table of normal probabilities, they came from a computer doing numerical methods. So there's other things that you might have done. I don't know, that you remember that were particularly painful maybe? Integration could be pretty painful, couldn't it? I mean, even when you know how to do it, you're like, I don't want to. So. Series, yeah, sequences and series, yeah. So let me think. Numerical methods. Let's see. How would I write that? I'm just trying to think because I know we do. So we're going to be solving equations. So if you want to know what are we doing in numerical methods? Well, one thing is solving equations. Can you solve an equation? Can you teach a computer to solve an equation? I know you can. Well, you know you can because you have Google. But we're going to learn how the computer does it. Same thing goes with integration, things like linear algebra. So all the techniques that you use to solve problems in all the application courses, the sequences and series, I hate to tell you, but that's sort of the main tool that we're using to do our numerical methods. So it'll be okay, though. It's going to be okay. We're mainly using them as a framework to say, look, this works, and so we can utilize that to make the computer do it for us. We're not going to really do a lot of sequences and series, although actually right off the bat, we're going to have to talk about errors. But it'll be okay. Oh, oh yeah, I guess I got stuck on the course description, didn't I? And that's why I'm doing this. I realized I haven't done, well, it's okay. So are there any other things that you dreaded when you were doing them in some sort of analytic setting? So things like integration. You did slopes differentiation, right? We did some of that. So we can do that numerically. There's linear algebra that we could do, couldn't we? Well, yeah, so we could get the computer to do all the drudge work for us. In fact, let me go back to this course description that's found in the catalog. A study of systems and equations sounds like linear algebra, doesn't it? Quadrature. What a fancy name. All that means is integration. So doing definite integrals, that's what quadrature is. Approximation of solutions, that's solving equations. So these are just fancy words that make people think that we're really smart. So we're doing approximating solutions of nonlinear equations, because obviously if you have a linear equation, hopefully everyone can solve a linear equation, maybe even in your head. Special emphasis is given to error analysis. So here's the second half, and this is kind of the dark side, which is going to be a little bit annoying, is that each time we solve something, and this is where we're going to have to rely somewhat on the sequences in series, is to figure out the error analysis. That is to say, we're going to approximate a solution. So if I write down an equation, let's do that right now. I want to solve this equation. The sine of x squared is equal to 2. So I want to solve that equation. Actually, that's not a hard, yeah, that's too easy. But that's okay. Here, how about 2x cubed? Now it's hard. Okay, so I want to solve that equation. Let's say I solve that equation numerically. I'm obviously not going to get an analytic answer like the square root of 7 over pi, but I will get a decimal, and error analysis is the question of how close can I expect my answer to be to the truth. So there is some true answer to this. You can actually you can see that there is some true answer because I can graph that. And when I graph that, I get something like this. Here's 2x cubed, and here's sine of x squared. Oh, no, sorry. That's better. It goes down through 0. Okay, and it gets, yeah, whatever. My graph is terrible. But you can see they cross at several places. And in fact, one of those places is 0. So x equals 0 is the kind of trivial, easy solution. But it crosses at other places. Where are those places? Well, numerical methods will be able to tell us, but how close we're going to be is the error analysis. And for that, did we hit everything in the definition? Machine community. Yeah, we're going to have to deal with a little bit of Python in here. I hope that doesn't surprise or shock anyone, or maybe not surprise, maybe dismay. It's going to be okay. It's going to be less than I had planned. I'll explain why in a bit. Okay, that's that. So that's what should have been printed here for the course description and the prerequisite. There are 2 textbooks. Both of them are available online. I'll show you right now where they are. I don't know if this makes you happy or sad. But yeah, I got an email from the bookstore late last semester. They're like, hey, where's the textbook? And I'm like, I thought I was going to use online. Do I have to tell you? And they're like, no, you don't. So I have links on our Moodle page. There's textbook, test book. Here, we'll just fix that right now. I'm typing too quickly, apparently. Not test book, it is textbook. Textbook number 1 is called P-Time Numerical Analysis, available for free online. And these are, this one's Open Textbook Library. The other one is a Springer textbook, and it's free as well. So these are real textbooks. So Programming for Computations with Python 3.6. So yeah, it's a gentle, I like the subtitle better than the title, a gentle introduction to numerical simulations with Python 3.6. So the point of this, I guess the reason for this is that numerical methods are, by their very nature, long, tedious processes. And so if we can avoid having to do them by hand, it would be nice. We will do some of them by hand, but you will find that they are long and tedious processes. We want to avoid having to do them if we can. So that's why we're going to use some Python, but we'll keep it relatively easy. And for reasons that I will show you, I've had to kind of change my perspective, let's say, on how we use Python. So if we get to it, I'll show you, yeah, we'll get to that in a bit. Okay, so you have the course objectives, which you don't really care about. Course policies, you do care about. Although if you've had a class with me before, you know already what I'm about to say, but I'm going to say it anyway. So class attendance, you have to come every day. And if you miss, of course, I understand that we are all adults, and sometimes you miss because you're sick. Sometimes you miss because you just choose not to come. But I would encourage you to come as often as you can. So there is a class attendance policy, and the policy, this is for our entire institution, is that if you miss more than 3 full weeks, so this would be for us, more than 9 class periods. That's 10. So if you miss 10, you get administratively withdrawn from the course. That's outlined in this class attendance thing here. It also details on that page. Oh, yeah, you can't really click that link on the piece of paper, but this is available on here. Yeah, syllabus there. So if you want to click something, you can go here and you can click class attendance, and then you can see what it says. So that's from the MVNU, basically the catalog. So yeah, basically, if you're going to miss, just let me know. Communicate. That's super important. So late work, yeah, you know this deal too. I penalize late work, but I'm not like I don't drop the hammer on you. Basically, you can. I'd rather you do it than not do it. So that's the deal. So you'll be penalized, but I'm not gonna. It'll have to be like 2 months late for it to not be worth anything. The quizzes can never be made up, so you'll get a quiz. It'll be short, easy, but if you miss, I don't do that. So if it's unexcused, then you get a 0. If it's excused, you get a blank. It doesn't count. Let's see, tests, you know the deal. Communicate. Let me know if you're going to miss a test because of golf, whatever the deal is. So yeah, and then the last thing under late work, I understand there's planned absences for school-sponsored trips, blah, blah, blah. Just, let me know. Classroom decorum, laptops, cell phones, tablets are prohibited, should not be used in class unless you're explicitly told to by your instructor. Tablets can be used for note-taking. Now this is a little bit different in here though, because it's numerical methods. We're going to be using the computer quite a bit. So don't fret. Anyway, mainly I just left that in there from my other classes because I don't want you playing Clash Royale or whatever else you want to do on your phone. So don't do just you're all so far away. We can always move closer to if that helps you. But yeah, especially in this class, probably I should just say that we're going to be using our laptops somewhat frequently. I'll let you know. But yeah, so if you're into taking notes on your laptop, as long as you're not watching the March Madness, it's fine. Okay, on the back we have the course grades. So we have some exams. So very similar to what you probably had with me before. So you have some exams, and I've got the dates there. Those are targets. I'm pretty sure that 2/21 I'll have an exam, mainly because that's the day before spring break. So don't plan to fly out until after this class. Daily assignments, you'll have daily assignments. Do I have the first one? I think I might have the first one online. I don't think it's going to be due. I'll let you know when to do it. Daily quizzes, like I mentioned, that'll be those of you who've had me, it's not that big of a deal. Projects, so the projects are going to be stuff dealing with computers. So more on that later. And then comprehensive final exam, I have the date and time there, but if you're not sure about the date and time of your other exams, I was kind enough to reproduce the entire final exam schedule on here, because I know some professors have difficulty being able to interpret this table. So our class is 12:50 on Monday, Wednesday, Friday, so that's that. And so did I do this correctly? April 29th at 10 o'clock? I did. Good. So anyway, you can check for your other classes. I can remember, I don't know, it might have been a dozen years ago, a student came to me and said, I have an exam scheduled at the same time as yours. What should I do about it? And I was like, you've got to go to the other professor and tell them that they have the wrong time, because these are pretty clear. So anyway, this helps everyone, I figure, because it's hard to find this. It's on the portal, but who knows where it is. Okay, blah, blah. We got some university policies. Okay, I'll do this quickly because most of you have had me before. Academic integrity, don't cheat. It's bad. Bad things happen to you if you cheat. But you can, if you're not sure what those bad things are, you can click the link up there online. There's an additional statement about AI that I thought didn't apply to me until I started preparing for this class. And then I realized it does apply. I'll show you why in a bit. Accessibility services. If you need to access the accessibility services, please do so. There's information on the syllabus, but if you need help understanding what that means, you can come talk to me. There's the Title 6, 7, and 9 compliance. I'm always baffled by what happened to Title 8, but at least those other ones we do care about. And so if you do feel like you've been discriminated against on the basis of race, color, sex, national origin, age, disability, or military service, please do seek out help with some sort of resolution to the issue. And you can go to the reporting form online. You can go to the Office of Civil Rights. So there's various places that you can go. Then one final note. By the way, all of these things, I'm just required. Everyone, all faculty are required to put these on their syllabus. So you've probably seen them on all the other syllabi. But this last one I thought was interesting because I usually at least mention this, but I had a friend, colleague say that they had to deal with this. And I said, well, don't you just tell the students up front? And this professor was like, oh, I guess that would be a good idea, wouldn't it? So like if you're in the English department, for example, people are writing essays all the time. And if someone writes an essay describing some sort of sexual assault that happened last week, then I'm a mandatory reporter. That's what this last paragraph, the last thing is about, is that faculty are mandatory reporters, which means that if you tell us something about something bad, which there's nothing, I don't want to discourage you from confiding in your faculty or staff members, but like RDs and so forth, they are required by law to basically, in certain circumstances, immediately dial 911. There are a few places on campus, they're listed here. If you do not want to have something automatically, like if you're described, like, I don't know, I've never had any, I guess students know that, I don't know, no one's ever, I've never felt like I needed to report anything, so I have no idea what this would involve, but like, I guess if you had some sort of abuse from I don't know. But if you wanted to talk about things like that without immediately having to get it reported, there are offices on campus, most notably the Counseling Center, the Spiritual Life Office, and then there are some faculty members who are non-mandatory reporters as a result of the fact that they are ordained in the Church of the Nazarene. So you can seek out one of them. I have a couple of them, four that I know of, who I can give out names if you need me to. So there's that. And then the final exam schedule. So that's it. I don't know why this has this blurb on it. Yours looks like it's a little different than the one I printed out. But I think everything's here except for the fact that I messed up on the course description. So what sorts of concerns, questions, worries, and fears do you have? All right, well, let's do it then. Oh, check out Moodle first. Let's see, what did I do? Where is Moodle? Right here. Give me a sec. Okay, so just so that you can see what's available, most of you already know about this, class videos. If you click that, you will be taken to my influencer account on YouTube, and you will find numerical methods are these the purple things this semester, and I'm going to try to do a little bit better of a job this semester in identifying what the class. So this is this class right now. If you want to relive the magic, go ahead and click that and watch. I don't know why anyone would, but Julia's not here, so I thought I should record this class. But anyway, in the past, I haven't been very good about adding the little title. So I'll try to indicate what it is. Like if we're going over a particular method, I'll put it in the title for the thing. But this is all just day one, so whatever. Yeah, and eventually this will populate kind of like I did in the fall. And you'll just look for those purple blobs with numerical methods and then look for the title. They will be in order from the, well, I guess you can sort them. Most popular? Oh, curious. Let's do it. Oh, apparently, what? 48 views? Why? That's amazing. 42 views? Why are people watching these things? Am I becoming an influencer? Maybe I can monetize this. Okay, amazing. Well, anyway, that was shocking. I got to be honest. Okay, so going back here, so that's the class videos thing. There's the two textbooks. Google Colab is the way that I was trying to figure out how I would have us use Python, and this seemed to be the easiest. My daughter told me about this. She works as a data scientist out in Boston area, and she said, we talked about Colab, and I was like, oh, what is this? And I checked it out. It's like, hey, that's a lot easier than having you either deal with the OSC website or downloading Python tier. I mean, there's nothing. I've got Python installed on this machine, but I don't know. So Google Colab, here's what it looks like. Well, here we'll just get a new one. Okay, new notebook. So it looks. You might, if you've used, what is it, Jupyter notebooks? It's sort of similar. But anyway, here's the reason why I realized I had to change the way I thought about this is that it says start coding or generate with AI. So it's right there. So and I tried it out and it was pretty good. It wasn't perfect, but I said, come up with a numerical method to solve an equation. And it's like, oh, there it is. It's like, okay. So anyway, well, despite that, I think that it's a good experience to do some coding ourselves and to become familiar with Python. And Python's not difficult, so it shouldn't be horrible, hopefully. But yeah, it's right there, Colab. I don't know if you have to have a Google account to use Colab, probably. So if that's going to be a problem, you can talk to me, let me know, and maybe we can cut a deal. I can have you download Jupyter Lab or something. Okay, so then under topic 1, I have homework assignments. I think there's just one thing there. Oh, there's no things there. Okay, I thought I put something in there. Well, eventually this will become a checklist with, seriously, there's nothing there. Yeah, okay. Well, it will eventually have stuff there. There's nothing for today, at least, so you can be happy about that. Oh, look, there's a bunch of stuff that showed up. Let's get rid of that junk. Here, clear.
I have a question.
Yes, what's up, Matthew?
So, on your YouTube, are there the previous classes for this class?
No, there are not. It's been too many years. I don't think. No, yeah. I started that particular channel. Yeah, they would exist somewhere, but not on that channel. I don't know where they are. They're on my other channel somewhere. Yeah, I didn't start using that in about a year ago. I started using that channel just because it was easier. It removed a couple of steps in getting the video up, and so it's just a way easier for me. Yeah. Oh yeah. So anything else? Other questions before we jump right in and start learning about what numerical? Like, there's some numerical methods we can do right now. All right, so I need an equation. I need an equation that I can't solve. So let's see, just a sec. We'll do this. We'll go back. I mean, I've got something that I was planning on doing, but I think this would be more fun, is to solve an equation. Okay, so let's see. Maybe we could put together like Frankenstein's, or put together a couple of different things. So let's see. I'll find a random person, random student. Okay, Zane's going to give me something, anything, any expression, not an equation, just something like sine of x or whatever. What comes into mind when you think of a mathematical expression?
5x squared.
5x squared, excellent. That's a nice, easy thing. Now, if I just put equals 2, that would be easy to solve. We could all solve it. So let's make it a little bit harder. We need some other thing. So non-polynomial now. So Eli, do you have something that's not a polynomial that I can add to this? So I'll just put a plus here. So that means it can't be just x squared, x cubed, but it could be something else. Oh, fancy. Yes, we can put a tangent in here. Tangent of x. Okay, and then we're going to let this equal something. We could pick a number, or we could pick another expression. So let's see, I'll let you decide. Briar, what do you think? What would you like to put on the other side of t cosine? Oh, cotangent of x. Okay, let's find out what this looks like. Okay, so I'm going to have to, I should have had something already set up here, but I didn't. Let's just go ahead and grab, let's use this. Let's see, can we generate? Let's generate. See if we can generate this. Just a sec. So let's graph this. So graph y equals, since, I mean, I figured Colab AI can do the heavy lifting for me, right? Plus tangent, I'll make it bigger in just a sec, sorry. So this is one side of the equation. Okay, there we go. Okay, so let's see how well this did. Let's see, I'll just run this cell. So this is the Python. Hopefully, I just figured, why should I do the, is it going to show me the plot? Oh yeah, there it is. Okay, interesting. Okay, so that is, if you're curious what this is, that's the left-hand side of this equation. And then let's do the same thing. Let's see, plot graph this and cotangent of x. Whoops, I should put a y there just so it's not confusing. Y equals cotangent x on the same axes. There it is. Try that. Let's see if it'll handle this. This is where I found I ran into some trouble, is when I tried to ask it to lump one thing on top of another. Sometimes it got confusing or confused. Okay, well, this looks pretty good though. It's setting up two plots. Okay, very nice. Oh, hey, yeah, excellent. So one thing I don't like about this is the fact that you have those discontinuities, but we should expect that, shouldn't we? Because we're dealing with trig functions. So you know what I think I'd like to do though, before we actually solve this numerically, is I'd like to change this, if you don't mind. So the cotangent is creative, but let's change that to cosine. And let's change the tangent to sine. Is that all right? I know that that makes it less exciting. But the reason is that all of those discontinuities are just annoying to look at. I mean, and also they create a situation where there's many solutions to this. So if you think of this as being an equation where the blue and the orange overlap, and the display here is not perfect. I probably could go in and make some adjustments to make it a little bit better, but you have this vertical line, of course, doesn't exist. This doesn't exist either. But you can see that where this curves up, it's going to cross the blue line here somewhere. And then right here, the blue and the orange lines cross. So everywhere these cross, you have a solution. Here's another solution. Blue and orange cross. Here, the blue and the orange cross. Here they cross. So there's a whole bunch of solutions. There's going to be an infinite number of solutions. Because of the discontinuities, it doesn't matter. So, so to avoid this, maybe we could just switch. I like the tangent. I like that, but do this. Or arctangent would be good. No, let's not go there. Let's just stick with the sine and cosine. So let's just go back and change this around a little bit more. And then we're going to talk about how we would solve this. You might have already learned to solve this at some point, because this is a topic that sometimes gets covered in calculus. Calculus 1, in fact. It's an application of the derivative. But let's just see how well if the AI did a good job. Okay, yeah, that's pretty good. Yeah, I like that. I'm going to make an adjustment. Let's see, -2 to 2. So yeah, so as you might have expected, because cosine and sine are not as crazy as tangent and cotangent, you have the cosine curve down here. And then this is that 5x squared plus sine of x. And you can see that they cross two places, so only two solutions. Let me zoom in on those two solutions. So let's go find, where is this defined? Just a minute. Plot. I thought that it was, okay, so I guess I can just change this right here. So this defines I'm going to go from -2 to 2, and then run this cell one more time, and then we'll be done. We'll just talk about this on the iPad. Ah, yeah, that's much better. So you can see, oh, I could go -1 to 1. That'd be even better. Yeah, so what this does is it sets up a set of points, and then it graphs, whoops, darn it, sorry. I think it's Control Shift Enter. Does that run? Yeah, that runs the cell. Okay, yeah, so there it is. You can see there's two solutions. Where are they? I don't know. We're going to find out though. So very nice. So let's use this. Okay, so here's the idea uh, um, that actually Isaac Newton came up with. Newton came up with a method to solve this. You might have learned about this in your calculus class, but here's the idea: is we're going to move this over so that you have a function is equal to 0. So sine of x minus cosine of x is equal to 0. So we have this curve. So now I've got a function, f of x is equal to 5x squared plus sine of x minus cosine of x. In fact, all of the solution methods that we're going to go over, 1250 to 150, right? It used to be that we had different times. I get confused. Okay, so this is the function, and all of the root, what these are called, they're called root finding methods, and it's one of the, will it be one of the first things? It's just an easy thing to point to as this is numerical methods, because you might have done it in calculus. So anyway, all of them work the same way. You start off with a function, and you're trying to find out where does that function equal 0. So to do Newton's method, so here I'll just write this down, Newton method. Here is the idea. Well, here, I'll first of all do this part because this is easy. So go ahead and do the derivative. I know you're excited to be able to do it, so let me pick someone to do it for us. Oh, we've already bugged you. Alyssa, do you know the derivative of this function? That's perfect. Nice job. So we've got the derivative. Now you might say, well, why would we need the derivative? Well, it's because like most of the methods that we're going to be looking at, we're going to take a function and we're going to pretend that it is linear. We're going to use a linear approximation to that function and then use that to solve the problem. Here, I'll actually do this here we go. So let's see. I also need a starting point. Sorry, I should have picked one. So we're going to start with something easy. X equals 0, y equals -1. So where did I get the -1 from? It's from plugging 0 into this. So that's going to be my starting point. That's obviously not my answer because my answer will have y equals 0. So I'll start with that. And then what we're going to do is we're going to come up with a tangent line. So let's do that. Let's come up with a tangent line. So I guess that what I need to do is I need to figure out what f prime of 0 is. So you can plug this in, can't you? Let's see, I'll just find someone. Sam, can you plug 0 into this f prime for me? Yeah, one of them is 1 and one of them is 0, but we got them both there, so you could just say just one. Yeah. For future reference, though, the cosine of 0 is 1, the sine of 0 is 0. Okay, very nice. So the derivative, that is going to be the slope of the tangent line. And now you can do this in one of several ways. I kind of like the linearization formula. So to use for a tangent line, let's do that. The linearization formula is you would do f of x0 plus f prime of x0 times x minus x0. So let's see if we can do this. This will be f of x0 is this, -1. It's kind of like your starting point. And then plus the slope, f prime of x0, it's right here, 1 times x minus 0. You could also do this just by coming up, you have the slope, you have the point. You could come up with your point-slope form of the line, which would work just as well. So, whoa, no, what just happened? Why did it do that? Okay, sorry about that. Okay, so this is my, here, I'll do it like this. Y is equal to this stuff. So y is equal to -1 plus x. And then now we can solve this. So remember, the goal is we want to, what is our goal? Oh, our goal is to solve this equation. And so set this equal to 0, and we get a new value for x. Wait a minute. Yeah, we get a new value for x. X equals 1. Okay, but what happened here is you have this function. Maybe I should graph it up here. Give me a sec. I'll graph it up on Colab. Wait, where is my Colab? There it is. Give me a sec. Okay. So maybe I'll just start a new, we'll generate. I know this is cheating in a major way, but it's going to be simpler, quicker. So here, actually I can just modify this. Hold on a sec. So graph, we're going to just graph this. Get rid of this. There. There. Because that's what, if you remember up here, if I'm trying to solve that equation, the top one, the way that numerical methods works is we first of all move everything to one side and have an equation that we can find the root. It's a root finding method, and so that's the new equation. So that's what we're actually solving, even though it's the same essentially. So I don't need to say on the same axis. Let's just see what this does for us. And okay, yeah, let's just see what this looks like. Okay, very nice. So you can see that there are two solutions. It's the same two solutions. And now I'd want to go and modify this some, but so I started off with my guess here. So I just wanted to take a look at that to see what it looked like. So apparently here's what this is looking like to me. Okay, that's not a very good rendition. Sorry, you can't even see it. Okay, so you've got this. So I started out with my first guess. Guess number 1, x equals 0. Now you plug that x equals 0 into the function and you find that it's not the correct answer because f of x, f of 0, is not equal to 0. It's equal to -1. So we found the slope. We found the linearization. And we got a new approximation. This is guess number 2. X equals 1. Is x equals 1 the correct answer? I think we can probably figure out that it is not. But we could take that new guess and do the same thing that we just did. So basically, over and over again, you have a guess, figure out what the function value is. That'll be f of 1 is equal to whatever it is. Come up with the linearization. Find out where that linearization crosses the x-axis, and then that's our next guess. And you do that repeatedly until you're satisfied that you're close enough to the answer. So we'll go over this. This is called Newton's method. It's pretty easy, and we can code this. In fact, I could code it right now by just telling that AI thing to code it, but I'm not going to do that when we actually are studying it for real, because it would be helpful to see how each of the steps works. Not only because that's what this course is about, but also because when we get to test time and so forth, you're going to want to know how the steps work so you can do it like this with an actual function. Okay, so that's what that is. Now, I'll get back to PowerPoint because there is something that I did want to cover today. We have 10 minutes. Sure. Yeah. Okay, so this is a little bit of a reminder of something that you did in Calculus 1. So over the next 2 days, so today and Monday, I need to remind you of two things that you did in Calculus 1. One thing you did in Calculus 1 and one thing you did in Calculus 2. So in Calc 1, you learned about the mean value theorem, and you probably just let it go because how useful is it? Well, it's incredibly useful in numerical methods when we talk about how close are we to the truth. So mean value theorem, let's see, where are we? Do we really? No, we don't want to do that. Here it is. We'll just cut to the important stuff. So here's the mean value theorem. It's pretty straightforward. What the mean value theorem says is that if you take a function, so that's what this is, between 2 points, A and B, and you draw a line connecting f of A with f of B, then for sure there will be some point, maybe more than one, as is the case in this particular picture, but there will be some point between A and B where the slope of the tangent line is equal to the slope of this secant. So the red line that I just drew, that's a secant line connecting f of A with f of B. And all the mean value theorem says is that you're guaranteed that somewhere between here and here, you're going to be able to find a point, maybe more than one point, where this slope is the same as that slope. I know it seems kind of like innocuous, like why do we even care? Well, interestingly, I'll show you this. As you drive around Columbus, you will see signs similar to this on our roads. But there are towns in China where you will find, instead of commemorating things like the Mall, like Easton and Polaris, you will find that they've commemorated things like the mean value theorem. So here's the mean value theorem. It's on a bridge in Shenzhen, China, I want to say. I can't remember exactly, but it's in one of the towns in China, this picture. I've never been there, obviously, but I got this off the internet. But this is a restatement of the mean value theorem. The mean value theorem says that there is some place, so some number, so this is in place of C, that's an epsilon, by the way. There's some number in between A and B where, I'll just write this over here on the left, f prime of, I'll write it as C instead of epsilon, is equal to f of B minus f of A over B minus A. Now that there is the same as the slope of that tangent, or that secant line. Whoops, here, I never even did this. So this is the same as, so you'll find at least one point, as long as you have a continuous function between, if you have a discontinuity, obviously you could jump from here down to here and avoid that slope altogether. So, so do we really want to do any more of this? Oh, Rolle's theorem. Yeah, we'll do Rolle's theorem and then we'll call it a day. By the way, the mean in the mean value theorem refers to the average rate of change. There was a book that was written back in the 1990s called The Mathematician Reads a Newspaper by John Allen Paulos, where he just talks about various applications of mathematics that are kind of funny, I guess. Probably not to most people, but he talked about how when that if you have cars driving on like the thruway, for example, or toll roads in particular, where you have places where the cars are being, here's the car at this point and this point. Like back in the old days, you would get a ticket when you entered a toll road, like the New York State Thruway or the Pennsylvania Turnpike. You'd get like a little piece of paper, And that paper would have on it, where you entered and what time it was. And then when you exited, you would have a similar, you would turn it in and they would know where you drove from and how long it took you. So what Paulos suggested was that using the mean value theorem, police could just say, issue speeding tickets based on the fact that if your average speed was greater than the speed limit, they would know that at some point, based on the mean value theorem, at some point between point A and B, you would have been going that speed, probably faster. But anyway, that's what the mean value theorem says. The mean is just that the average. So the average speed between those 2 points would be, you would have to hit that at some point. And the same thing goes for any function, that the mean value theorem says that you would have that slope. Now, here's the last thing, and then we'll call it a day. And I'll tell you what you should be doing for Monday. So Rolle's theorem is a corollary to the mean value theorem. Rolle's theorem just says that if you have a function that is continuous, and if two function values agree with one another, then there's got to be at least one number between A and B such that the slope is 0. So here's what this means. If you draw a function, so here's A and here's B. If you pick these 2 points and draw a function that is both continuous and differentiable. So it's a key, I guess the mean value theorem, you also have to be differentiable. So that means no jumps, no corners, nothing weird. If you draw a smooth curve between these 2 points, you will not be able to do it without having at least one point where the slope is 0. You can see how this is similar to the mean value theorem. You're dealing with slopes. And so you can try this yourselves, is connect those 2 dots and try to avoid having a slope of 0. So let's go down here and keep going. Look, I'm not going to have a slope of 0. I guarantee it. Watch this. Oh. If I'm going to get up there, I'm going to have to curve. Okay, I had a slope of 0. There it is. There's no way to avoid it. So that's what Rolle's theorem says, is it's somewhere between there. You end up with a slope of 0. So I know that it's hard to imagine how this is used in right now for numerical methods, but I guess you'll have to trust me that this is kind of foundational to why numerical methods works. Okay, so we have no homework or normal type of homework for Monday because we're just sort of getting introductory. So what I'd like you to do is to download or do whatever you want to do with those textbooks. So you saw those 2 textbooks, so T-time numerical methods and then the computations for whatever for Python. So if you are normally would put them on your hard drive somewhere, then download them, make sure you know where they are, take a look at them, just open them up at least once so that you say, oh, look, that's a book. Okay, great. If you put them on your iPad, maybe that's the way that you like to read them, go ahead, get them downloaded, put them on your phone, whatever it is that you need to do so that you have access to them. And then on Monday, we'll begin for real, and you will have homework from the T-time numerical methods book. So the T-time numerical analysis, that's the one we'll use first, and then we'll learn about the method, and then we'll move on and use the Python thing to learn how to code the method. So that's the idea, is we'll toggle back and forth. All right, so I'm going to stop the recording. You can stick around and chat. Otherwise, have a great day and enjoy your weekend.